I just wanted to remind you of a couple things about the functions and its derivative and how we can use it to do some word problems. So the wind chill is the temperature in degrees Fahrenheit a human feels based on the air temperature in degrees Fahrenheit and the wind velocity v in miles per hour. If the air temperature is 32 degrees Fahrenheit, then the wind chill is given by that equation. And that's valid for wind speeds or wind velocities between 5 and 60. Okay, so let's assume that the temperature is 32 degrees Fahrenheit. So to find the wind chill, well, we have a wind chill equation, right? This is the wind chill equation. It's a function of velocity. So if the velocity is 20, all we're going to do is plug in 20 for W. Okay? And of course, the next question, find the wind chill if the wind velocity is 50. We'll just plug in 50. Now I'm going to rely on you to type that in with your calculator. I'm not going to take the time to do that because I want this to be a short video. But let me just remind you of one thing in AP Calc. Our answer should be to 3 decimals. Okay? Same thing here. We should be going to 3 decimals. So I think you get 19.90 something. You should give all 3 decimals. Okay? The next question says find the formula for rate. Well, rate means derivative. Okay, so we're going to find the derivative, dW dV. Okay? Well, to find the derivative of W, I guess the first thing we're going to do is notice that the derivative of 55.6 is 0 because that's a constant. The next piece, negative 22.1, will get multiplied by 0.16. If we do that, we get negative 3.536. And then the power drops by 1, so it becomes to the negative 0.84. Okay? So that's our derivative. Next, it says find W prime of 20. Well, of course, this just means we're going to plug 20 in right here for V. And after we've done that, we get our answer. Let me just talk about units. Okay. So dW, well, wind chill is in degrees Fahrenheit. Velocity is in miles per hour. So it will be degrees Fahrenheit per mile per hour. And explaining that in context, well, that means that our temperature, or excuse me, our wind chill, we should say, okay, is changing at a rate of, and of course you can calculate that, but we should also say at V equals 20. Because of course, depending what velocity is, that's going to change how fast the wind speed is changing. The one other thing I should tell you is that this answer comes out to be negative. So, you know, it's negative blah 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 something, which makes sense because as the velocity of the wind increases, the wind chill should be decreasing. It should be feeling colder. So again, a derivative is just telling us the rate of change. So, you know, in context, it means the wind chill is changing at a rate of whatever our answer was at the point that we plugged in.